Hello, dear students. Good evening to all. The most of the students will face difficulty to understand isomerism because isomerism is a very important topic to write a number of possible isomers with molecular formula. So, how we can overcome this problem? And isomerism also very important topic for various entrance examinations. So, let us crack this difficulty in our class. So, isomerism is our topic, today's topic. So let us start isomerism. Yes. So first of all, classification of isomerism. So before that, so the versatile property of organic compounds is isomerism. Because of this property, compounds with the same molecular formula, there are different compounds are possible. So there's a property which makes that organic compound separate from inorganic compounds. So that we'll discuss. So first of all, let me explain what are isomers. Isomers, right. So what are isomers? Isomers, like the compounds have same molecular formula. Compounds have same molecular formula, but different in properties. Same molecular formula, MF molecular formula, but different in their properties. Different in their properties. Right? They are called isomers. So isomers, a brief definition we have. One second, let me check this OBS stereo. Yeah. So compounds have same molecular formula but different in their properties. Different in their properties, they are called isomers. Example. A simplest example I would like to give here. What is example? Here, molecular formula C2H6O. This is a given molecular formula. Based on their connectivity, structure, how many isomers we can write? How many isomers we can write here? So let us take here like two isomers we can write with this molecular formula. One is CH3, CH2, it is OH. CH3, CH2, OH. And other compound is CH3O, CH3. Right. So there are two different compounds are possible. Two different compounds are possible. Like this compound is called alcohol. This compound is called ether. So one is alcohol, other one is ether. Their physical properties and chemical properties are different too. Even though they have same molecular formula. Hi, hello, hello. Good evening to all. So this is a basic idea that the compounds have same molecular formula but different in their properties. Different in their properties, you can tell in terms of what? You can tell in terms of physical properties and chemical properties. So physical properties and chemical properties are different. Such compounds are called isomers. So basic idea is what? Molecular formula should be same, right? So let us go for classification of isomerism and the study of this phenomena. This phenomena is known as what? Isomerism. The compounds exhibit different structures, different properties with the same molecular formula. That phenomenon is known as what? Isomerism. So classification of isomerism. Let us see here. Classification of isomerism. Classification. How do we classify isomers? On the basis of what? So isomers or isomerism, we can say. Isomerism first we can classify on the basis of connectivity of atoms. Connectivity of atoms. On what basis we are going to classify? Based on connectivity. If connectivity is same, connectivity different. That means isomerism mainly classified into two types. They are, one is a structural isomerism, structural isomerism, and second one is stereoisomerism. Structural isomerism and stereoisomerism. Yes. So on what basis we are going to classify? It is on the basis of what? Connectivity. Connectivity of atoms. Because atoms are connected through covalent bonds in the chain in the compound. So organic compounds are covalent compounds. So there are covalent bonds present between atoms. So on what basis we are going to classify? Based on connectivity. If connectivity is same or different, on the basis of that we are dividing the isomers into two types. So one is connectivity is same. Connectivity is same. Then connectivity is different. Connectivity is same and connectivity is different. On the basis of this, we are dividing the isomers into two types: structural isomers or structural isomerism, and say stereo isomerism. Right? Very good. Now, structural isomers further classified into, and one more thing you have to notice here. So, one more thing you have to notice that here connectivity is different. Here stereoisomers connectivity is same. It means based on this connectivity different, there will be different types of isomers arised. So further structural isomers are classified as following types. One is a chain isomerism. Chain isomerism. And the second one is positional isomerism. Positional isomerism. And the third one is functional isomerism. Due to different in connectivity of atoms, what are the possible isomers arised? They are chain isomers, positional isomers, functional isomers, that is functional isomerism, and metamerism, and say tautomerism. The last one is here, tautomerism. Right. Again, the stereoisomers actually connectivity is same, but what way they are different? Again, we can further classify these stereoisomers into two types. What are those? On what basis we are going to classify them? On the basis of, say, on the basis of spatial arrangement, spatial arrangement, spatial arrangement. So it is different. It is same. On the basis of this, we can classify the isomers as following types. What are those? They are first geometrical isomers, geometrical, and it is optical isomers. Geometrical isomers and optical isomers, right? So geometrical isomers and optical isomers. Here it is about restricted about rotation of. These are erased. Geometrical isomers are erased due to restricted about what? Carbon-carbon rotation. This point you have to notice. So where the compounds, there is a restriction, even carbon-carbon double bond system, and here it is due to differing rotation of plane polarized light, PPL. This part we'll discuss in further next classes. Alright. So if you look at this isomerism, isomers are divided mainly into two types, structural isomers and stereoisomers. Structural isomers further classified into chain isomers, positional isomers, functional isomers, metamers, and tautomers. Stereoisomers further classified as geometrical isomers and optical isomers. Here geometrical isomers, the spatial arrangement is different about what the restricted about carbon-carbon double bond or carbon-carbon rotation. Here, but here carbon-carbon rotation is allowed in this optical isomers, but they are differ in the rotation of what plane polarized light, isn't it? So this is the brief classification of isomers. Let us discuss one by one. So what are the structural isomers? When we call them as chain isomers, when we call them as positional isomers, when we call them as functional, and etc. We will discuss one by one. So let us start with a structural isomerism. Structural isomers. Under structural isomers, let me explain about chain isomers A. Chain isomers or chain isomerism. That phenomenon is isomerism. Right. So what way the chain isomers are different? If you have an idea about, this nomenclature part, you will get to know easily. What are chain isomers? This is also called as what? Skeleton or nuclear isomerism, also known as nuclear isomerism. Nuclear isomerism, right? So what is that condition for identifying that chain isomerism. Here, isomers which are differ, in you know root word, When if you see that IUPAC name, the root word or length of chain is different. This point is very very important. If they are different in the root word, definitely they come under which isomers? Chain isomers or nuclear isomers. Let me give example. Here it is. So in this case, here let me write 3 carbon system. 3 carbons are there. How many chains we can write here? 1, 2, 3. So only one type of chain is possible. Only one type of chain. Yeah. 1 second, let me. Sir, chapter wise weightage PDF. There is a sir. Yeah, sir. Hello. Hi. Hi everyone who are in the live. So it is only one chain is possible. Only one chain is possible. You can't write more than one chain, because what way you connect, you will get only continuation chain is probe only, right? If you connect like this or like this, if you make like this, or whatever the way you connect the 3 carbons, you will get only one type of chain. That is a probe chain, right? So what am sir, chapter wise weightage of Unnada sir? Yeah, it is available, but I will let you know in the next class. Chapter wise weightage I will give you. But it is better to cover all the chapters, Amma, because they are including all the chapters with equal weightage, so that but there are few chapters with good weightage. I'll let you know. I'll try to give you in the next class. Fine. So there are 3 carbons. We can make only. Yeah, I'll try. Manvita. So this is 3 carbon chain. 3 carbon chain. Only one chain is possible. Whatever the way you write, we can call it as it is probe. This is probe. This is also probe. Right? You can't write more than one type of chain with 3 carbons. If there in a molecular formula containing 3 carbons, so only one chain is possible. We can't write more than one chain. Fine. Suppose the carbon, if given formula contain 4 carbons, if given compound containing 4 carbons, then how many chains are possible? How many you can write? So you can write of these many chains, like carbon. There is 4 carbons in the straight chain. So this root word I can say but, and you can make one more chain with 3 carbons and one branch. Please, dear students, please let me know, is my voice is clear or not? Audio and video is clear or not? So there are 3 carbons chain and one is taken as what? Branch. Now this is a branch. So this is branch. However, the total carbons in this system, here and there are 4 carbons only. Yes, perfectly. Now this is but. Then what is the name of this root word? It is probe. We can't say it is but, right? So 4 carbons, how many chains we can write? 2 chains we can write. One is but chain, other one is what? Probe chain. Therefore, these two, suppose if I take this 1, this is 2. Now 1 and 2 are which isomers? Nuclear isomers, because they differ in their root word. They differ in their root word. Therefore, these are said to be nuclear or chain isomers. Nuclear or chain isomers, right? Therefore, if I give one example, say C4H10. So how many isomers are possible with this compound C4H10? So with this, there are two isomers you can write. One is N-butane, other one is isobutane. Again, you may get one doubt here. What are the common names? If you write common names, with common names we cannot differentiate whether they chain isomers or not, because with name, a common name, it is N-butane to the first compound name. It is N-butane, and this compound name is isobutane. Isobutane. N-butane, isobutane. If you look at this, you may get one doubt here. Sir, here but is the root word, here also but is root word. But what I'm saying, it is a common system. But when you write IUPAC name, so what are the IUPAC names of these compounds? IUPAC names. If you write about IUPAC names of these compounds, then it could be what? Butane. It could be butane. And this is 2-methyl propane. It is 2-methyl propane. Yes. So what is the root word? It is but. It is prop. Okay. This is a but root word. This is a prop root word. But number of carbons 4, number of hydrogens 10. Therefore, these two are said to be which isomers? Chain isomers. Hope you understand well. If you have any doubt, you can text me so that I will see and I will try to explain to you. Right? So with 4 carbons, how many chains are possible? Because to write the possible number of isomers, first basic idea is what? Writing of number of chains. Writing of possible chains. If you know the possible chains, then rest of the isomers easily we can write. It's not big issue. Suppose similarly, if I give 5 carbon system, given 5 carbons, there are 5 carbons are there. So 5 carbons means how many chains we can make it. That means a molecular formula containing 5 carbons. So whatever the hydrogens, oxygen, that doesn't matter. First you have to see that carbon skeleton. That's what I'm not showing hydrogen and other elements which are there in the molecular formula, because carbons are most important for chain isomers. So in this case, what are the chains possible? You can write it as carbon, carbon straight chain being like this, and one more chain you can write with root word is but, and one more chain you can write with the root word prop. We can make 2 branches here, right? Therefore, now this is root word is pent. Now root word is but. Here root word is prop. So, but overall number of carbons how many? In this compound there are 5 carbons. In this compound there are 5 carbons. In this compound there are 5 carbons. Therefore, IUPAC system, if you write it is propane, it is 2 comma 2 dimethyl. So 2 comma 2 dimethyl propane, and this is say 2 methyl. It is 2 methyl butane. It is a pentane, simple pentane. But what are the common names? If you look at the common names, they contain same root word. So that's better to consider IUPAC system. In the IUPAC name, if their root words are different, definitely they could be a chain isomers. So based on this, you can write it as this is N-pentane, N-pentane. This is isopentane, common name. This is neopentane. In the objective question, they give like this. So what type of question they supposed to ask you? N-pentane and isopentane are what type of isomers? Are isopentane and neopentane are what type of isomers? It means N-pentane, isopentane and neopentane are which isomers? Chain isomers. These two are chain isomers. These two are chain isomers. Even first and third also. These two also which isomers here? Chain isomers. Hope you understand. So you can draw line formula for this molecule like this, and isopentane being like this, and neopentane is like this. Right? Hope you understand. So what are chain isomers? How we can understand them? So in the IUPAC system, if root word is different, they could be definitely chain isomers. Okay, right. Next, if you see positional isomerism, second example under this structural isomers, the second one I'm going to explain, that is positional isomerism. So positional isomerism. Yes. So how do you write this? Isomers which are differing. Simply you can understand what are chain isomers, what are positional isomers, what are structural isomers, functional isomers, etc. Simply we can write isomers which are differ in what? Position of, you can say position of branch, okay, position of double or triple bond, or functional group. Functional group. Functional group. Therefore, how do you write it? The branch is nothing but what? Prefix position. So branching we can indicate in terms of prefix in the algebraic system. Prefix. And double bond, triple bond position, this part will indicate in terms of what? Primary suffix. So this is a primary suffix. Primary suffix positions are different. And this is, we can say, secondary suffix. Secondary suffix. So prefix position is different, or primary suffix position is different, or secondary suffix position is different. Isn't it? That means simply we can write how we can identify the position isomers. So except the positions, except numbers, that means a position, while we give numbering for a position of what? Branch or double bond or triple bond, except number, the IUPAC name, IUPAC name of isomers. IUPAC name of isomers is same, is similar. So this condition you have to see. Hello, mom. Hello, Fahad. So we can use here. That means simply there is a trick to distinguish what are positional isomers. So as I explained, isomers which are differ in position of branch or double bond or triple bond or functional group. That means branch we can indicate as prefix, and double bond triple bond is indicated as primary suffix, and functional group is secondary suffix. It may be different any one of them, so that when you write two isomers or more isomers, IUPAC names or IUPAC names, except these numbers, the remaining name, sir, EAMCET syllabus is reduced or not? No, it's not yet confirmed, because accordingly the mains they will follow for EAMCET. So not yet announced. After completion of this mains examination, they plan to conduct EAMCET. Fine. So let us write some examples of positional isomers. Hope you understand the definition and how there is a trick. With this trick, we can distinguish whether these given isomers are positional isomers or not. Right? Example. Example. Here, molecular formula, I can say C3H7. Sir, where are you from? Yeah, I'm from Hyderabad. C3H7Cl. So if it is C3H7Cl, how many isomers we can write? First let us take with 3 carbons. 3 carbons means, as we discussed in the structure chain isomerism, how many chains are possible? Only one type of chain is possible. So we can make one chain, and of course I'm making here one more chain being like this. Yeah, further I'll let you know later. So yeah. Okay, that's great. So here this 3 carbon system is there, therefore I can make 2 chains. So that why I am making 2 chains, because I want to differentiate the position of chlorine. Chlorine is the first position, here chlorine is the second position. Right? If you add the rest of the hydrogens, like the rest of the valencies of carbon, CH3, it is CH2. This is sir, please tell me where in Hyderabad. Yeah, I tell you, Fahad, I tell you. The CH2Cl. Now what could be it is CH3? It is CH3, right? This is H, right? Hydrogens and chlorine and everything is balanced with 2 compounds. Perfect. Yes. So what is the name of this compound? What is the name of this compound? Here it is probe chain. Here it is probe chain. So let us write a probe chain. Therefore, I can say, if you ignore the position of a substrate, it is propane, it is chloro, right? Chloropropane. And what about this? It is also chloropropane. It is also chloropropane, right? Perfect. But what way they are different? Yes, as we discussed, the position of a branch. Suppose the chlorine is a branch here. Here chlorine is a branch. Now if you take the chlorine position, is my voice is echo? Really? Let me check once. Now check once. File check once. Is it okay? Now it is. So let us put it is 1 chloro. File check my voice. Now it's clear. Thank you very much. It is 2 chloro. So 1 chloropropane and 2 chloropropane. Right? So what is the difference here? This position is different. 1 and this is 2. But rest of the name is same as this. Same. So simply I can say these are said to be which isomers? They are said to be positional isomers. Positional isomers. Of course, easy to identify the given isomers, they are positional or not. I give one trick here. So just we can differentiate with these positions. Okay, I'll give one more example. Come on, I want to use different pens because colors are very effective. Yes. So in this case, sir, please your no. Why I'll let you know later. I'll let you know. Right. C3H7Cl, therefore it is 2 1 chloro, it is 2 chloropropanes. These are positional isomers. Right. One more example I would like to give here. Suppose C4H8. C4H8. With this, how many isomers possible? Okay, I gave here with 4 carbons, how many chains are possible? Chains, how many possible? 2. Clearly, I explained in the first case how many chain isomers are possible. Chains are possible with 4 carbons. So how I can make it is 1, 2, 3, 4. Perfect. And one more chain. 1, 2, 3. I can make one branch. Right. So definitely there is a degree of unsaturation is 1. That means I could put one pi bond in between 2 carbons. Therefore, so if I put one double bond here and I can put one double bond here, right, and even I can put one double bond over there in the middle carbon here. Of course, with reference to this carbon, all positions are equivalent. 1, 2, 3. Wherever you put between this carbon, first carbon, this carbon, third carbon, this carbon, second carbon, you will get same type of compound. Therefore, all are equivalent positions. The such positions are called equivalent positions. Is it? Again, my voice is echo. Really? I set my audio, but I don't know. Let me check again. Yes. Now check once. Okay, fine. So here, if you look at this, so what is the name of compound? If you add hydrogens corresponding, like here 3 valencies are required, here it is 2 valencies required, here 1 valence is CH, and this is CH2. And here how many valencies required? It is 3, it is 1, here it is 1, here it is 3. 5. So total 8 hydrogens satisfied. Okay, here 3 valencies, here 3 valencies, here 2 valencies satisfied. Okay, among these 3 possibilities, 3 structures, this compound name is what? This compound name is but-1-ene. Very sweet name. And what is it? It is but-say-2-ene. Perfect. And this is it butane? Are you sure? What is the name of this compound? This is 2-methyl but. No, it is prop. So 2-methyl propene. Propene. 2-methyl propene. Okay. Now, in this case, 2-methyl propene, but-1-ene, but-2-ene. Yes, let us compare 3 structures. Now let us make the relation between 3 possible structures with C4H8. Okay, come on, try. Let us take this is a numbering. I can say A, I can label it as A, B, C. This is C. Okay, fine. So I use one different color to make very attractive. So can I use white? Yes. Yeah. Fahad, just follow my class. This is sufficient to you. So in this case, if you look at this, like what are the isomers here? A comma A comma BR. These two. A comma B. A comma BR. Which isomers? A comma BR positional isomers. Why? How do you identify whether the positional isomers or not? You see, but 1 in, but 2 in. Only numbering wise they are different. But IUPAC name is same, but 1 in, butene. Right? Very simple. And A comma C. A comma C are which isomers? Yes? Come on, tell me. A comma C are which isomers? Yes? Tell me. What is the answer? A comma C. Exactly, they are chain isomers. Why they are chain isomers? Chain isomers. Right? Why? You could look at this. It is propo, it is but, they are not same root words. Therefore, again, they are chain isomers. Right? Again, what about B and C? B comma C also chain isomers. So hope you understand what way we can differentiate if say, same molecular formula they come under which category, which type of isomers we can easily distinguish it is. Okay, then one more example I would like to give here with a secondary suffix different. Say C3H C3H 8OH. Otherwise, you can take it as general molecular formula. Propanol, 2 propanol, 1 propanol. Simply I can write it as 1 propanol and 2 propanol. 1 propanol, 2 propanol are which isomers? Simply you can say positional isomers. Why they are positional isomers? Any idea? Yes, it is very simple. Again, what is the trick we play here? It is 1, it is 2, but rest of the names are same. Therefore, if you draw the structure of 1 propanol, if you draw the structure of 2 propanol, you can put OH at first position. It is OH. I think is blue color visible. Is it visible or not visible? Yes. So if there is OH, here there is OH. Therefore, they are positional isomers. Likewise, we can write number of examples. Say one is benzene, chlorobenzene, dichlorobenzenes. You can write here. Dichlorobenzene. How many positional isomers we can write with the dichlorobenzene? Dichlorobenzene. How many positional isomers we can write? Yes. So I'm not showing the positions here. So let us write the possible isomers. Here it is benzene, and here it is one more benzene and one more benzene. Okay. So therefore, you can put chlorine here and here, here and here. This is what are the positions. If you give numbering, chlorine. Come on, tell me what is it? It is 1 comma 2. It is 1 comma 3. This is 1 comma 4. Right? So these are all Names are what? Dichlorobenzenes. Dichlorobenzene. So this name is 1, 2 dichlorobenzene. It is 1, 3 dichlorobenzene. It is 1, 4 dichlorobenzene. So therefore, except their positions, names are same. That is the reason I can say they are which isomers. They are simply, these three are said to be positional isomers. Positional isomers. So isomerism, right? Isomers, I can say. Isomers. Okay, right. So dichlorobenzene. So because the carbon, you can replace one hydrogen with one substance. That's what you cannot put two chlorines on same carbon. So if I ask you one question, that what is the question I would like to ask you? So question, write down. So what is that? Number of positional isomers. Please let me know who are there in the live. Just what are the voice and this visibility of how is the visibility and audio. Number of positional isomers of dichlorocyclopentane. I'm asking. Dichlorocyclopentane. So I'm giving options. A, it is B, it is C, it is D. Right? So I'm giving options like 4, 3, 2, let us take 5. Yes, I'm waiting for your response. Do respond. So what is the correct answer? Yes, come on. Yeah. So here the answer is, okay, after solving, let us come to know otherwise how many isomers are possible. Right. See, if it is cyclopentane system, how do you write it is? So it will be like this. Now you can put on same position two chlorine atoms. It is 1, 1. So that means 1, 1 dichlorocyclopentane and 1, 2 dichlorocyclopentane and 1, 3 dichlorocyclopentane. Can we write 1, 4? No. 1, 4 dichlorocyclopentane we can't write, because if you give numbering from here 1, this is 2, this is 3, this is 4, this is 5. But if you put chlorine and this thing, like if you have two structures, yes, here it is chlorine and this is chlorine. So these two compounds are same. They are not different. So if you give numbering from this side anti-clockwise, you can give 1, 2, 3, this 4, this 5. You give numbering from this side 1, 2, 3, this 4, this is 5. So both are 1, 3 dichlorocyclopentanes only. Therefore, how many positional isomers are possible? 1, 1, 1, 2, 1, 3. Therefore, answer is B. So 3 isomers are possible. with dichlorocyclopentane systems. Not only this chlorine, any two substances you can put like two methyls, two hydrox groups, like two nitro groups, anything, or two different groups or two same groups, up to you. That is just positional isomers means these may only possible with a dichlorocyclopentane system. Hope you understand, right? So what is the conclusion here? If you look at this, what is the condition for positional isomerism? The isomers which are differ in their branch, the double bond, triple bond position or functional group position. It means you can except except number, the IUPAC name of isomers, okay na, is similar. Okay, that's what you have to understand. So fine. So let us move to the next isomerism. What is that? That is said to be a functional group isomerism. C. So functional isomerism. Functional isomerism. So what is functional isomerism? Yes, it is one of the important isomerism in the structural. So functional isomerism is what? Simply we can say isomers which are differ in functional group, differ in functional group. That means what is a functional group? How we indicate in the IUPAC system? Functional group means say secondary suffix. Functional group, secondary suffix. Isomers which are differ in functional group, and rest of the part like root word, prefixes, primary suffix may be different, may be same, isn't it? So and root word, that means length of chain, may or may not similar, may not same, like but, prop, like that. Okay, let us see different examples. Like examples, let me write with the molecular formula. There are different possible molecular formulas are there. So among those first we'll discuss one by one from starting. I can say one example like CN H2N plus 2. So this is the hydrocarbon formula because compound containing carbon and hydrogen only. In this case, so no functional isomers possible. If compound is obeying this formula, then simply we can say isomerism. Which isomerism? Say functional isomerism is not possible. So no functional isomerism is possible. No functional isomerism is possible. No functional isomerism is possible, right? Similarly, if you write why it is so, because it is saturated hydrocarbon. Saturated hydrocarbon. So what type of isomers possible with this hydrocarbon? Therefore, under structural isomerism, we can write two isomers. What are those? With these isomers, we can write one is say chain isomerism. So chain isomers are possible, and the second one is positional isomers are possible. Positional isomers are possible. Apart from that, under structural, no other isomers are possible. Only these two we can write with a molecular formula CnH2n plus 2. Okay, under structural I'm talking about, not stereo. Under structural, if you have that given compound formula is CnH2n plus 2, then simply we can write what are the possible isomers, means chain isomers we can write as well as positional isomers we can write, but functional group isomers are not possible. Okay, that thing you have to remember. And let's go for next formula, next example. Say one is like CnH2n. So CnH2n, how many isomers are possible? With CnH2n, if you see, alkenes are possible and cycloalkanes are possible. Alkenes and cycloalkanes. So alkenes and cycloalkanes are type of what? Functional isomers and also known as ring chain isomers. Ring chain isomers. So do remember, whenever the given formula obey this one, fit in CnH2n general formula, then you can write possible isomers alkenes and cycloalkanes. So ring chain isomers are say type of what? Functional isomers. Because why they are classified as functional isomers? Because their reactivity is different, functionality is different. So therefore they are said to be what? Functional isomers, we can say. Example, suppose if I write like a C4, let's start with the minimum carbons. Minimum carbons means how many carbons we can write? C3H6. Okay, is it correct, the formula matching with this? Yes. So alkenes means 3 carbons, 1 double bond. Okay, and cycloalkanes, 3 carbons in the form of ring. Therefore these two are which isomers? Ring chain isomers. So these are example of a ring chain isomers. Ring chain isomers. Understood? Similarly, if you write 4 carbon system like a C4H8, because should be obey the formula like this, C4H8. So how many isomers we can write? Alkenes and cycloalkenes. Alkenes means how many chains are possible? So 2 chains are possible. One is this chain and other one is a prop chain. So I can make this a bute chain, prop chain. With this bute chain, I can put double bond because it is not a C4H10, it is C4H8. Therefore, we have to put one double bond. Degree of unsaturation is 1. So here it is. With this, all positions are equivalent. Therefore, you can put any place one double bond. Understood? Right. Now, and also we can write cycloalkanes means cyclobutane we can write, and methyl cyclopropane also we can write. So these two are again which isomers said to be chain, because bute prop both are rings, and these two are again which isomers? They are positional isomers. Again these two are which isomers? Chain isomers. But this open chain system and this ring chain, so these are what? Ring chain isomers. Hope you understand. So with the molecular formula CnH2n, so ring chain isomers are possible. So they are a type of functional isomers. Hope you understand. So in the next class we will continue with remaining functional isomers, what are the molecular formulas, what are the possible isomers. Until, thank you very much for watching my live class. Close it.